Now, turns out that if a net torque causes an angular acceleration, if I have a zero net torque, that should cause a zero angular acceleration, by which I mean a constant omega. Now, that could either be something that's stopped or something that's rotating at a constant rate, the same omega all the time. And we also find that if we double the torque, we double the alpha. Now, on Wednesday, we're going to find out what the constant of proportionality is, but for now, this is just an observation. Now, in order to solve problems using torque, we need to go back and understand what Friday's lecture was all about. I'm sorry, forgot this was in here. On Friday, we decided that the center of mass would seek a point directly below the support. And at that point, it would be happy. Now, if we think of this in terms of torque, if we draw a line of action away from this force, it's going to go right through that pivot point. That means my lever arm is going to be zero. That means the torque is going to be zero, and it's just going to stay right there. If, on the other hand, I slide this over to the right, now the weight force is acting right here, and if I extend that into a line of action, I get a lever arm that's non-zero. That's going to give me a torque that's going to cause rotation back to that place of stability where the lever arm goes to zero. Now, instead of using the lever arm method, I could take the useful force method. If I take all of the position vector and just the part of this weight vector that's perpendicular to the distance vector, I would also have a torque. And that torque would cause it to rotate back to the position directly below the support.